Okay, so now let's look at a problem. The problem is to find the length of this parabolic segment r equals 6 over 1 plus cosine theta, and theta is from 0 to pi over 2. So this is a problem. We're gonna use a formula regarding to the polar coordinates. So the length of the curve, so the length of the curve in polar coordinates r equals f of theta is integral from alpha to beta square root of r squared plus dr d theta square and then d theta. Okay, so what we'll do here is we will use this problem to figure it out. Okay, so that's how do we do this problem. So let's get started here. So first of all, the alpha and beta is given. It's from 0 to pi over 2. So r is here, dr d theta. We need to figure out what is dr d theta. So dr d theta here. So as you can see that we can apply the quotient rule to figure it out. That will be 1 plus cosine theta squared, right? So it's this times the derivative of 6, and then minus 6 times the derivative of the denominator, which gives us is negative sine theta. So it turns out this gives us is 6 sine theta over 1 plus cosine theta square. Okay. So we got our dr d theta. So what we need to do next is to put everything back into this integral formula. That is from 0 to pi over 2. So you're going to have square root of, it's going to be 6 plus, over 1 plus cosine theta square, right? And then plus 6 sine theta over 1 plus cosine theta square, and then square, and then d theta here. Okay, so that's what do we get so far? Looks like it's a little bit complex at this stage. However, as you can see that we actually can factor this 6 over 1 plus cosine theta square, from this square root. So let me show step by step. So turns out this is what we can get. Square, we're going to have 1 plus. So we're going to have it's a sine square, right? Because 6 square is here, and then over, and it's a 1 plus cosine theta square. Okay, and then d theta. Okay, d theta. And turns out that, so what we can do is first either we can bring it outside, or maybe we can simplify a little bit for this to see if there is something we can do. Okay, so what I'll do here is I'll simplify inside this bracket to see what happened. So I have this, and then so it's 6 over 1 plus cosine theta square, and you will see that I'm going to have 1 plus cosine theta then square over 1 plus cosine theta square, and then plus sine square theta, right? And then d theta here. Okay, so it turns out there is something we can simplify, because if you expand this part, maybe I can just use this little space to show this, because this part, it's going to be 1 plus 2 cosine theta, right, plus cosine square, and then plus sine square theta. So that's for the denominator for this part. And turns out this part is 1, right? So I'm going to have 1 plus 2 cosine theta, and then plus 1. And then that is 2 plus 2 cosine theta. Turns out I can even write it as 2 times 1 plus cosine theta here. Okay. So this is the simplified expression for the numerator inside of this bracket. So if we replace this, and then this is what I get. So you're going to have from 0 to pi over 2, big square root of 6 over 1 plus cosine theta the square. Well, this is also a square. And then multiply. Realizing that, you see on the top here, it's 2 times 1 plus cosine theta. On the denominator is 1 plus cosine theta squared. So basically, 1 plus cosine theta can be simplified. So it turns out you're going to have it's a 2 over 1 plus cosine theta. Okay, 1 plus cosine theta. So that's the simplification so far, d theta. So now, as you can see that at this stage, what do we get? Well, turns out we can have it, this is from 0 to pi over 2, 6 square root of 2, and then over the so this part is going to become into 1 plus cosine theta cube, right? But you also have a square root, so it becomes into 1 plus cosine theta cube, and then the square root d theta. And then we can do a little bit more, which is 6 square root of 2 over 1 plus cosine theta to the power of 3/2. Okay, if we rewrite it into an exponent form. So now, up to this stage, things is pretty good. And the next part is, you see this part is 1 plus cosine theta, right? And then to the power of 3/2. So for this specific part, we're going to need one trig identity to help us simplify this process. That is, this trig identity going to be 1 plus cosine theta equals 2 cosine square of theta over 2. Okay. So right now, if we apply this trig identity to here, what we get it here is from 0 to pi over 2, 6 square root of 2 over 2 cosine square theta over 2, and then to the power of 3/2. Okay, and then d theta. Okay, so this is what we got so far. Let's use a new page to continue. So it turns out that, you see, we will have from 0 to pi over 2, 6 square root of 2 over, you see that you're going to have 2 to the power of 3/2, which is going to give you, it's a 2 square root of 2. Okay, so you apply this 3/2 to 2 here, and then multiply cosine of square, and then to the power of 3/2, it becomes into cosine cubic of theta over 2, and then d theta. Okay, so a lot of stuff getting involved here, but since will become clear soon. So it turns out that this part equals 3, so we're going to have a 3 integral from 0 to pi over 2, 1 over cosine cube theta over 2, right, and then d theta. Now, what you will see here is we can also rewrite the problem into secant cubed theta over 2 d theta. Okay. So far, the problem becomes, how to solve for this integral problem. Okay. So to make the problem a little bit more easier to solve, what we can do here is I want to make a quick substitution that is let u equals theta over 2. So du gonna equals to d theta over 2 here. Okay, and of course, when you make this u substitution before theta is from 0 to pi over 2, right now u kind of becomes so theta is from 0 to pi over 2. So corresponding u kind of becomes from 0 to pi over 4. Okay. So after that, this is what we can do. We can have 0 to pi over 4. We're going to have it's a secant cube u, and it's du. So d theta equals 2 times du. So it's 2 times du here. Okay. So let me write it into. So it's d theta equals 2 times du. So it's times 2 du. So if I bring this 2 in the front, problem becomes into 6 from 0 to pi over 4 secant cube u du. Okay. So pretty long process. After we got to here, the problem becomes, okay, how do I start to evaluate this integral, right? So it's also not a very straightforward process. So, but let me show you quickly here. Turns out we can do. So you're going to use the integration by parts for this one, because as you can see that secant square u du, actually if we set this is u, this is a dv, so if I set this is the integration by parts here, so basically what you will have, you're going to have it's secant u times tan u. Okay. And then, of course, do the evaluation from 0 to pi over 4, okay, minus the integral, which is tan, which is the, let me see what we have here. So this is u, this is dv, right? So we're going to have its tan u, and then times the derivative of secant u with respect to u. It's going to give you it's a secant u times tan u here. So it's going to give you secant u tan u on du. And so again, it's from 0 to pi over 4. Okay. And turns out, so it is pretty complex. I have to admit about that. And then minus, so the integral from 0 to pi over 4. And turns out that, this is a tan square, right, times secant. So we have tan square u secant u du. But don't forget that secant tan square actually equals, so let's get involved now, the identity, which is tan square of u equals secant square of u excuse me, minus 1. Okay, so we're gonna borrow this trig identity to here. So so the problem becomes so it's 6 secant u tant u from 0 to pi over 4 minus integral. So you're going to have it's secant squared u minus 1 times secant u on du here. So if you distribute it, you will see and then minus integral from 0 to pi over 4, you're going to have secant cubic u minus secant u and then du. Okay, and then du. So now the thing is, you see guys, don't forget it's in the very beginning, up to this stage, we are evaluating this guy. Okay. And then you see after I doing integration by parts and apply a trig identity, realizing that so this part you know actually it like appears again. So we know that under this situation, so let me use another page to explain. So the thing is, if we you know ignore the limits, so the secant u on du here, it actually equals secant u tant u minus secant u and then minus cubic and then minus secant u on du here. So you see we can bring it out into secant u tan u minus integral of secant cubic u du and then plus integral of secant u du. So you see that we actually can solve this expression algebraically. So it turns out that the integral secant cubic of u du equals 1 over 2 of secant u tant u, and then the integral of secant u, it equals natural log of absolute value of secant u plus tan of u here. Okay, and then of course you need to plus a constant c because this is indefinite integral. But for the problem we are handling is a definite integral, so you can see the final stage, if you recall what we got here, it gonna becomes into 6 and then times 1 over 2 secant u tant u plus ln of secant u plus tant u and then evaluated from 0 to pi over 4. Okay, so it's an extremely long problem. So you will see this is going to become 3, and then the tant of pi over 4 equals 1. The secant of pi over 4 actually equals square root of 2. Okay, square root of 2. So you're gonna see that it's a square root of 2 times 1 plus ln of square root of 2 plus 1. Okay, and then minus and then tan of 0, it is 0. Okay, and then so this part it's it's 0, and then also for this part is minus ln of, this is 0, secant of 0 is equal to 1, right? And then so ln of 1 is also 0. So the final answer, it gonna becomes into 3 times square root of 2 plus ln of square root of 2 plus 1. And then, so of course you can simplify into 3 square root of 2 plus 3 ln of square root of 2 plus 1. Okay, so that's the end of the problem. It's pretty long, and it's a little bit complex, so it's a very comprehensive problem. Basically, it's getting involved with the polar coordinates, the length formula in polar coordinates, and also getting involved with a couple of trig identities. Also the technique of integration by parts, and also one of the result about the integral of secant, which is ln of secant, absolute value of secant plus 10. Okay, so it's pretty comprehensive problem. So hope you you enjoyed, and thank you for the watching.